everyone, my name is Ogenetidru Mamogo and you are welcome to Oakscam Academy. Now if you are new to my channel, kindly hit the subscription button below, also like, share and of course avail yourself to the lessons so as not to be left behind. Welcome back. So in today's lesson, we're going to be learning a very important topic in chemistry titled gas laws. I'm sure a lot of us are familiar with gas laws. We're going to be emphasizing on the calculations under gas laws. We're going to be taking them step by step from Boyle's law to Charles' law to general gas law and so on and so forth. Well, first things first, when we talk about gas laws, I want to believe sometime in your school year you learned about states of matter, and then we learned that we have 3 states of matter, although it is 4, but emphasis on 3, which is what our solid, liquid and gaseous state. So when we talked about these states of matter, we're going to be emphasizing on what the gaseous states of matter. So under the gaseous states of matter, there are certain laws that are responsible for how gaseous particles behave the way they are, and that is why we learned kinetic theory of gases. But for now, we're going to be emphasizing on what the calculations under what gas laws. So we're going to be starting with what Boyle's laws, and I'm going to be defining what Boyle's law is. So what is Boyle's law? Now Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure, provided that temperature remains constant. So Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure, provided that temperature remains constant. So please do well to learn this definition of Boyle's law. So, but that said, our emphasis in Boyle's law is what? Pressure and volume, provided that what? Temperature remains constant. So what is the mathematical expression of Boyle's law? V is equal to what? 1 over P, where our V is volume and our P is pressure. So V is equal to what? 1 over P. V is volume and P is what? Pressure. So inversely proportional. That is to say, when volume increases, pressure decreases, and when pressure increases, volume decreases. So that's the meaning of what? Inversely. So that said, we have questions on the board and we're going to be solving so as to better understand how to calculate Boyle's law. So the first question on the board, and the question says 375 centimeter cube of a gas has a pressure of 770 millimeter mercury. So this is what? Millimeter mercury. Find its volume if the pressure is reduced to 750 millimeter mercury. So question, how do we know that this is a Boyle's law question? Because when you are giving all this kind of calculations, you are not told whether it is Boyle's law or Charles' law, general gas law. You are expected to know what it is by looking at the question. So how do we identify that this is a Boyle's law question? I will tell you why. Because we are dealing with pressure and volume. Remember, we said for Boyle's law, our emphasis is on what? Pressure and volume. So when the question has to do with pressure and volume, know that that is a Boyle's law question. So that said, what is the formula for Boyle's law? So it's V1 P1 equals to V2 P2. So this is the formula for Boyle's law. V1 P1 is equal to V2 P2. So the first thing when you are solving any calculation, I always advise that you write your formula first. When you write your formula, it makes everything easy on the eyes. So this is our formula for Boyle's law. So now that we have written our formula, the next thing I advise is that you write out your prerequisites, that is your values. Okay, so I want to substitute them. So V1, V2, P1, P2. So these are your values. So according to the question, what is our V1? So please take note, one of the ways students miss calculations in gas law is when you don't know your units. So if you don't know that the unit of volume is centimeter cube, you will not know that this is volume. So please take out time to learn. I will be dropping some units in the video, but please take out time to learn the units of your volume, your pressure, your temperature. Okay, so centimeter cube is a unit of volume, dm cube is a unit of volume, liter is a unit of volume, and so on and so forth. So because this is 375 centimeter cube, we know that this is volume. So this is our V1. So 375. So what is our V2? Mind you, the question says find its volume. So please take note. Find it, meaning that we're looking for what? Volume. So we're going to put a question mark on V2. What is our P1? we're told that the gas has a pressure of 770 millimeter mercury. Millimeter mercury is a unit of pressure. The same way kilopascal is a unit of pressure. Like I said, take note of your units. So because we know that millimeter mercury is a unit of pressure, then we know that this is what P1. So 770. And what is P2? 750 millimeter mercury. Now that we have written our values, we're going to be making V2 subject of the formula, because why? We are looking for what? V2. So how do we do that? V2 will be equal to, now this is our formula, V1 P1 equals to V2 P2. So since we're looking for V2, one of the easiest ways to make stories of the formula is this. The one that is attached to what you are looking for. So in this case, we're looking for V2. P2 is attached to V2. So P2 will come down. So this is a very simple way of writing this formula. The one attached to the one you are looking for comes down. Then the other one is on top. So V1 P1. Okay? So this is our formula. So now we can now substitute our values. So V2 is equal to, so what's our V1? 375 times, what's our P1? 770 over, what's our P2? 750. So V2, so we can use our calculator to quickly do that. So if you have a calculator, do that on your own. 375 times 770 divided by 750. So our answer is 385. So this is our answer. Well, can we leave our answer like that? No. In gas laws, units are very important. So because we are looking for volume, what is the volume of units given in the question? Centimeter cube. So our answer is 385 centimeter cube. Had it been we were giving dm cube or liter in the question, our unit answer will be what is given in what? The question. So I hope we understand that. So if you understand this, let's take another question, and then we'll be able to better comprehend Boyle's law. So for the second question, we're told a gas occupies 12.3 liters at a pressure of 40.0 millimeter mercury. What is the volume when the pressure is increased to 60.0 millimeter mercury? Okay, so like I said, you write out your formula. V1 P1 equals to V2 P2. Then the next step is to write out. So the next step is to write out your parameters. What is our parameter? So V1, V2, P1, P2. So what is our V1? We'll go back to our question. The question says 12.3 liters. So that liters, remember, is a unit of volume. So we know that this is volume. So 12.3. What did the question say we should look for? Volume. What is the word volume? So we know we're looking for V2. I think I would advise that when you write out your parameters, first of all, identify what you are looking for before you start filling in your values to make things simpler for you. So what's our P1? Pressure. Remember, millimeter mercury is a unit of pressure. So what? Our P1 is 40.0. What's our P2? 60.0. So we're written that out. So we're going to make V2 solve the formula. We can simply copy what we did in the first one. But like I said, the one attached to the one that you are looking for goes under. So V1 P1 over P2. So what is our V2? We're going to write down our values. Our V1 is 12.3 times our P1 is 40 over 60.0. So let's solve that very quickly. So 12.3 times 40.0 divided by 60.0. So our answer is 8.2. So is it just 8.2? No, because why? We're looking for volume, and the unit of volume given in the question is liters. So you see 8.2 liters. So we did not say 8.2 cm cube because cm cube was not what was used in the question. What was used was liters, and so our answer must be in what? Liters. So this is how we solve Boyle's law. I want to believe what we have solved so far, we can attempt these questions on our own. So as much as possible, please try to pause the video, attempt to solve, then play it and see if you are correct. So but that said, let's solve number 3. So the third question says, if a gas at 25 degrees Celsius occupies 3.60 liters at a pressure of 1.0 atm, what will be its volume at a pressure of what? 2.50 atm. So it's the same thing. So write our formula, V1 P1 equals to V2 P2. Write our parameters, V1 V2 P1 P2. So what's our, like I said, identify what you are looking for first. The question says what will be the volume, so we're looking for V2. So what's our V1? Remember, liter is a unit of pressure, of volume rather. Liter is a unit of volume, so 3.60 is our V1. What's our P1? Now it said a pressure of 1.0 atm. Even if it has not said a pressure of, we should know by now that atm is a unit of pressure. That's atm is atmospheric pressure, so it's a unit of pressure. So our P1 is 1.00 and our P2 is 2.50. So we've written out our values. So now let's write our formula. It's the same formula we'll be using because we're still looking for V2. So V2 is equal to what? V1 P1 all over what? P2. So what's our V2? Our V1, 3.60 times 1.00 all over 2.50. So let's quickly do that calculation. So 3.60 times 1.00 divided by 2.50. So our answer is 1.44. So what's the unit of our answer? Liters. Why? Because we're giving our volume in what? Liters. So our answer is 1.44 liters. I hope it's very simple. Okay, so that is just it. Now I know some of you may have a question. You may say, Ma, we're giving 25 degrees Celsius in the question, how come we did not use it? Remember, when we're stating Boyle's law, we said that provided that temperature remains constant. So even though they put temperature here, it's just to let you know what the temperature is at these parameters. So it's not you're not supposed to use it. Please don't be confused. You're not supposed to use it. It's not part of your question. They're just trying to let you know what the temperature is for this question. But as long as it has to do with volume and pressure, we are dealing with Boyle's law. So don't confuse this for a Charles law question, because we're not asked anything about temperature. Temperature is just there to let us know what it is for this question. I hope you understand that. So we're going to be solving the last question. I want to believe if you were able to solve this on your own before you saw it in the video, let me know in the comment section below. And also attempt to solve this, play the video to see if you were correct, and then if you're able to get it before I solved it, let me also know in the comment section below. So that's it. The last question is, a gas occupies 1.56 liters at 1.00 atm. What will be the volume of the gas if the pressure becomes 3.00 atm? Now I know we will say, is there a volume that we are solving for? Actually not. When it has to do with Boyle's law, you can be asked to solve for volume, you can be asked to solve for pressure. It's still the same thing. Okay, there's no difference. It's just the same format. So we're going to be solving the way we have previously solved. You write your formula, V1 P1 equals to V2 P2. You write our parameters, V1 V2 P1 P2. Okay, so what is our V1? Our V1 is what? 1.56 liters. What's our V2? That's what we're looking for. So question mark. What's our P1? 1.00. Remember, atm is a unit of pressure. And what's our P2? 3.00. So the same subject of the formula, V1 over P1 over P2. So V2 is equal to 1.56 times 1.00 all over 3.00. So let's quickly check what that is. So 1.56 times 1.00 divided by 3.00. So our answer is 0.52, and our unit is what? Liters, because that's what we were giving it. So the answer for this is liters. I hope you understand. If you have any questions pertaining to this lesson, please let me know in the comment section below. Also, if there are other questions you would love me to solve for you, also let me know in the comment section below. Till next class, I remain your tutor, Ogenete Jomamogo. Have a wonderful day.